All right, so welcome back to the last section of the fluid mechanics portion of the Civil FE exam review. Today we're going to be looking at energy, impulse, and momentum of fluids. So I got some interactive problems for today that aren't super complicated, but let's go ahead and get into them. So number one says, the density of air flowing in a duct is 1.15 kilogram per meter cubed. A Pitot tube is placed in the duct as shown. The static pressure in the duct is measured in a wall tap and pressure gauge. Use the gauge readings to determine the velocity of the air. All right. So, what are we trying? What are we given? Right. Well, we're given the density of air. We are also, what else are we given? We're given pressure readings. Of the static pressure coming in and out. Right. Okay. So we're also given that this is a Pitot tube. Right. What are we trying to find? Right. We're trying to find the velocity of the air. So, velocity. Okay. Are there any formulas that we need? Well, first and foremost, let's also get these readings. For those of you who it's kind of hard to see, it's like it's coming in at 6 times 10 to the third pascals. And it's going out at 7 times 10 to the third pascals. Okay. So those are our readings coming in and coming out. All right, so let's start by just searching Pitot tube because I don't see if we can find a formula that we can use. So I do a search. All right, Pitot tubes. Okay, so V is the velocity of the fluid. Well, in this case, it's going to be air. But the stagnation pressure and the static pressure. So of the fluid at the elevation where the measurement is taken. So PS is the start, and P0 is where it ends. All right, so it ends. So this would be our P0, and the static pressure, the fluid at the where the measurement is taken, is here. So that's going to be our PS. Okay. And what else is in this formula? So we get the velocity of the fluid. So V is equal to square root 2 over the density. That's what rho stands for. Times P0 minus PS. Now, do we know what rho is? Yes, we know the density of the air, right? This is rho. All right, so we have rho, we have P0, and we have PS. Now it's just time to solve, right? All right. So when I solve this, I get square root of 2 over 1.15 kg per m cubed. Okay. And then 7 times 10 to the third PA minus 6 times 10 to the third PA. Okay. So we have to know that our units don't match. So once we bring this over, we get, and I'll just bring this up here. It's going to transfer everything that we're doing up here. So I get 2 square root of 2 over 1.15 kg m to the third times 1,000 pascals. Right. All right. How do we get pascals to go into kilograms or get some units to cancel, right? All right. So let's go to our unit conversions section to see if that'll help us. All right. So 1 Pascal equals 1 Newton per meter squared. So we'll start there. So 1 Pascal is equal to what is it? Newton over meter squared. So 1 Newton over meter squared. Okay. So I'll be able to switch that unit into Newton over meter squared, but that's still not going to cancel out my units completely. So is there anything, can I get this Newton? What is a Newton? So 1 Newton, and we'll change the color. So 1, can we get that in kilograms or something so that units can start canceling? So 1 Newton is equal to 1 kilogram times meters over second squared. One kg/m over second squared. Okay, so now let's take this and substitute it into our newtons. All right. So now 1 Pascal. So 1 PA is equal to 1 is equal to 1 kg times m over s squared. And then all of that over meters squared. And so that simplifies to it just being kg over m dot s squared. Okay, so 1 kPa equals 1 kg over meters times second squared. All right, cool. Now that we have all of that, now we know that we can substitute these units into here. We just want units. We just want units that will make sure that things cancel. All right. All right. So let's do some erasing. Hopefully you wrote this stuff down. All right. So the last step would just be us, again, substituting the values that we need. And this is all for velocity, right? So get velocity is equal to square root 2 over 1.15 kilogram per meter cubed times 1,000. And instead of PA, we're going to put kg over m times s squared. All right. And all of this is going to unit wise is going to be should be meters to the these are going to cancel, right? So we're going to get our answer in a meter squared over, our units are going to be meters squared over second squared. But we're going to take the square root of that, and it's going to give us our meters over seconds. And so the answer is going to be 41.7 meters per second. So units are the main thing here. We want to make sure that we have the right units. And so that was very tricky, but we do all that because we want to make sure that we fully understand what we're doing. So our answer is going to be A, closest thing to the answer. Not a hard problem, just a lot of unit conversions. So let's look at number 2. All right, this one says, if the fluid is water at 20 degrees Celsius and height 1 is 0.2 meters and atmospheric pressure is 101 kPa, kilopascals. What is the absolute pressure? All right. So what are we given? We're given the fluid type, which is water, and temperature. We're also given H1 and P ATM, or atmospheric pressure. Okay. And what are we trying to find? Absolute pressure. Okay. So I don't know how to get this, so I'm just going to do a search for absolute pressure. Alrighty. So just going to move my head out of the way. So what I'm seeing here is that the absolute pressure is equal to the atmospheric pressure plus the gauge pressure reading. Okay. So how do I get the gauge pressure reading? Well, first of all, that's going to be, should be unit weight times H. See. Should be my unit weight times H. Or it can be the fluid density. Yeah, so here. Unit weight times H, so, or not unit weight, but specific weight of the fluid times the H, which is H1 in our case. So the formulas that we need is P ab, let's try that again. P absolute is equal to atmospheric pressure plus pressure from the gauge. And the pressure from the gauge is going to be, or what is our atmospheric pressure to start? So should be equal to 101 kPa. All right. So how do I get my gauge pressure? So P gauge is equal to unit weight, or specific weight, not unit weight, but specific weight times my height. All right. What is my specific weight of water? Well, typically it would be this, right? The 9,810 newtons per meter cubed. But key thing here is they give it that changes based off of the temperature that we have. So in this particular case, we need to find the unit weight of water at 20 degrees Celsius. All right. Are we able to get that information? Well, let's look up. This should be in our properties of water. I'll just search water. Aha. And in fluid mechanics, they give you the properties of water in English units and in metric units, and we need metric units. So our specific weight for the temperature, that is 20, is this, right? 9.789 kilonewtons per meter cubed. Okay, so we have that. So now my gauge pressure of the gauge, writing is a bit atrocious. 9.789 kilonewtons per meter cubed times 0.2 meters. And so I get, for my pressure gauge reading, I get 1.9578 kilonewton per meters squared. Okay. From there, I can plug that into here, right? Into my pressure gauge reading. I have both. But are my units? What are my units? So I got 101 kilopascals plus kilonewton over a meter squared. So I need to get this in the same units to be able to add these up. So what is 1 Pascal? Let's go to our unit conversions. All right, so 1 Pascal equals 1 Newton per meter squared. Okay. So that means that if I have 1.9578 . Clearly I'm tripping. All right, so 1.9578 kilonewton per meter squared. If I want it to be in pascals, I know that 1 Pascal equals 1 Newton over meters squared, and therefore 1 kPa is equal to 1 kilonewton per meter squared. I just multiplied both sides by 1,000. And so now I know that 1 kilonewton per meter squared is equal to 1 kPa. So now my units cancel and I'm left with 1.9578 kPa. All right, so both are in kilopascals, and now I can plug that into my formula down here. So 101 kPa plus 1.9578 kPa, and we are left with 102.95 kilopascals. Right. So closest thing to that is A at 103 kilopascals. So I kept these units, like I did 1.9578, and you don't have to do all those. Just at least want to keep probably to about 3 decimal places just to make sure you're tracking your numbers, especially if your answers are pretty close together. But in this case, they weren't. So yeah, A is going to be our answer. Very, very important. Units in fluid mechanics. They're probably not going to make you change a ton of units, but you need to be familiar with pascals, newtons, getting newtons to kilograms and meters and seconds, and playing with those and getting your answer in the right units. The worst thing that can happen to you is you be on the test, you know what to do, but you don't know how to get the answer in the units that they're wanting. So you want to make sure you're doing this type of practice now so that you can prevent that. All right, let's look at number 3. This one says, calculate the kinetic energy of a fluid with a mass flow rate of 2 kilograms per second and a velocity of 10 meters per second. All right, so given mass flow rate 2 kg, and we're given the velocity of 10 meters per second. We want to find the kinetic energy of the fluid. What formulas do we need? All right, so what is kinetic energy? I'm going to search energy. Searching kinetic energy. All right. So I get T, which is T and VI respectively, the kinetic and potential energy. So T is kinetic energy. So I get T is equal to 1/2. I'm just looking at this. 1/2 mv n squared. All right. Do we have mass for a unit of time? Yes. Do we have volume? I mean, not volume, but velocity? Yes. And it tells us V is the velocity. So anytime if you don't know what the units are or what the symbols represent, you have to read so that you know. Read the manual to be able to determine these things. Okay, so the kinetic energy of this fluid is going to be T is equal to 1/2 times mass is 2 kg times the velocity and we're going to square it. All right. So now you should get 100 comes out to 100 joules. And how do we know it's in joules? So let's go to our unit conversions. What is a joule? So these units came out to be kg meters squared. Yep. So if that was the case, this is the same thing as saying 1 Newton times meter. And then from there, that equals 1 joule. So that's how we were able to get this in joules. So answer is C. Hopefully that made sense. And this concludes the fluid mechanics section of your civil FE exam as you're studying for this thing. And let's look at the next topic. And anytime you need to navigate this manual, definitely use the bookmarks. Really helps. Click on civil and the next section is going to be surveying. So you're almost there. Let's keep working so that we can pass this civil FE exam. I'll see you in the next video.